Okay, so number one, we're going to make our table of values. It says to use at least 2. I like to use 3, so I'm going to do that. You don't have to, since it says otherwise. 3 to the negative 1 is 1/3, 3 to the 0 is 1, 3 to the 1 is 3. Let's see, state the domain and range for part A. I guess I could go ahead and do that right now. So domain is all reals when it's exponential. Range, it's not shifted, so it's just going to be y is greater than 0. B, stating transformations, there are none. C, state whether the graph has a horizontal and vertical asymptote. This is a horizontal asymptote, and it's at the line y equals 0. And D, state the equation of the asymptote. Oh, sorry, I just gave that y equals 0. So we've got negative 1 1/3, 0 1 1/3. Connect the dots. There's our picture. Number 2, so all reals again. Our range, it's not flipped over, so it's going to be y is greater than. It got shifted down 1, so it's y is greater than negative 1. We had a vertical stretch because of that 4. It's going to go left 3, and it's going to go down 1. It's going to be horizontal asymptote, and it's going to be y equals the k value of negative 1. Let's make a table of values. If I'm looking at just the parent function, and I'm looking at the parent function with the a, so I'm just stripping away the h and the k. So 5 times 4 is 20. 4, and then 4/5, which is 0.8. I'm going to subtract 3 from the x's, so negative 4, negative 3, and negative 2. Subtract 1 from the y's, so 19, 3, and negative 9. Can't really do any of those very well unless I go by 2's. Can't even do that. Got to go by something even larger than that. Oh, actually, I shouldn't have I don't know why I have a negative 9 here. I thought that was a negative. Okay, my bad. I will be able to do this. Subtracting 1 from 0.8, so I get negative 0.2. Okay, sorry about that. So negative 3, 3, negative 2, and then negative 0.2. My asymptote is at negative 1. I'm not going to bother graphing negative 4, 19. So following your asymptote curve and hit those points. Number 3, I won't have to do any transformations other than it's a vertical stretch, because that's 6. Domains all reals. Oops. Range is going to be y is greater than 0, since there's no vertical shifting. It's a horizontal asymptote, and that asymptote is y equals 0. Those 2 points are the only ones that really are going to fit on my graph. Start approaching that 0. Now we get into logs. So it might be helpful to think about the associated exponentials, like y equals 3 to the x. If I were doing that one, I'd do negative 0, 1, negative 1, 0, and 1, giving me 1/3, or 0.33, 1, and 3. But now, since it's a log, I'm going to switch those around. So my negative 1, 0, and 1 goes in my y column. My 0.33, 1, and 3 goes in my x column. Domain now, it's going to be x is greater than my h, which is 0. Range is going to be all reals. Transformations, there are none. It's going to be a vertical asymptote now since it's a log, and it's going to be x equals whatever my h is, which is 0. So our graph looks like that. I'm going to go ahead and go without the other function and just realize, think about 3 to the x. I would have a negative 1, 0, and 1 for the x's, but I'm now to go y's. So 3 to the negative 1 would be 1/3. 3 to the 0 would be 1, 3 to 1 would be 3, so I just kind of get it switched around. And now I have to raise it up to, so 1, 2, and 3. Don't have to do anything to my x's. Domain, it did not get shifted vertically, or horizontally, I guess, so my vertical asymptote is still going to be at x equals 0. So my domain is x is greater than that. My range is going to be all reals. It went up 2 is the only transformation. And then number 6. So my x's would have been a negative 1, 0, 1. 3 to the negative 1 is 1/3, or 0.33. 3 to the 0 is 1. 3 to the 1 is 3. Now I'm going left 2, so I'm subtracting 2 from my x's. My asymptote got shifted to the left, so x equals negative 2 is my asymptote, still a vertical asymptote. Left 2 is the only transformation. Domain is that x is greater than negative 2. Range is all reals. And there's my graph. Now I move into some word problems. Okay, the number of subscribers increase, so it's growing exponentially. Was 285. It's growing 75%, so 0.75. They're talking just number of t years, so I can put a t there. There's my equation. You can call that parentheses 1.75 if you like. So how many cell phone subscribers are there in 2005? So the initial amount was 285. I've got a 1.75 to the power of, so t is measuring the number of years since 1985, so this would be 20 years later, so an exponent of 20. So I'll plug that in the calculator. 285, 1.75 to the power of 20, giving me an answer of 20,682,633 people, or subscribers. Question number 8, ibuprofen, it's decreasing, it's exponential decay. They took 400 milligrams, that was the initial amount. 1 minus, it's decreasing by 29%, so 0.29. And this is each hour. So x is going to represent hours. So in part B, 6 hours. So we've got 400. You can leave it as 1 minus 0.29 if you'd like, or you can call it 0.71. That's what you would get if you subtract it. We're talking about 6 hours. So 400.71 to the 6th power, 51.24 milligrams. 51.24 milligrams. Now we've got to write function. So here's our initial value. The 8 is our initial value, and then we have a xy that we're going to plug in temporarily. So y is 22,048. Initial value is 8. I don't know my growth factor. Just leave it as a g. It's to the power of x, which is 4. So first thing I'm going to do is take my 2048 and divide it by 8, giving me 256. equals g to the fourth, and so then I'm going to do the fourth root. I know I'm only looking for the positive, so I'll do the fourth root of 256. I can also, if I don't want to go into the math menu, I can just hit 256 to the power of 1/4, since I know that can also be written as a fraction, and that's 4. So my growth factor is 4. So now make sure you write the equation, y equals your initial amount, 8, times your growth factor, which is 4 to the power of x. So there's our answer. I'll repeat that process now with number 10. I'm going to divide by negative 0.2, so negative 3.125 divided by negative 0.2 gives us 15.625. I'm going to take that to the power of the reciprocal, so negative 1/3. So instead of converting it to fractions, I can just type that in just as it is. So 15.625 to the power of negative 1/3. That's going to give me my answer of 0.4. So since that's less than 1, we know it's a decreasing problem. It's exponential decay. My initial amount was negative 0.2. 0.4 is my growth factor to the power of x. All right, let's take a look at the back page. 64 is a power of 4, so I'm going to write them both as powers of the same base. It's 4 to the third. Distribute. So 4 to the 3x minus 9. Exponents can be equal to each other. So x has to be 13. Oh, actually, hold on a second. I made a mistake. That was a negative 9, not a negative, not a positive 9. So let me adjust real quick. Sorry, I'm going to get some white out here. Okay, so I had a negative 9. I'm subtracting 35, so I should add a negative 44 there. So x then would be a positive 22. All right, number 12, I can write these both as powers of 2. 2 to the negative 1, to the x minus 3, 2 to the fourth, to the 3x plus 1. Distribute negative x plus 3 for the first exponent, 12x plus 4 for the second exponent, set them equal to each other. Negative 13x equals 1, so x is a negative 1/13. Just going to glance that over, make sure I didn't make a mistake. That seems like a little bit of an unexpected answer. That doesn't mean it's wrong, but I just want to make sure I didn't make a mistake again that time. I believe I did all right. Okay. Number 13, we've got an inequality. They're both powers of 6. 36 is 6 squared. Since it's in the denominator, I'm going to bring it up. So 6 to the negative second. And then over on the right side, I have 6 to the third. Distribute exponents. Up minus 16, not plus. I should probably slow down a little bit. I'm trying to hurry. Making some mistakes. 3x minus 9. Now I can set the exponents, or drop the bases, basically. Subtract 3x. Add 16. Divided by negative, that's going to switch my inequality sign. So I believe I get that x is greater than or equal to negative 7/5. Number 14, all we're doing is having to rewrite it. So you can do 3 to the 5th power is equal to 243. This one we're rewriting 5 to the negative 2 is equal to 1/25. Write as logs. Log base 2 of 8 is equal to 3. Log base 1/3 of 1/9 is equal to 2. 5 to the second power is 25. Here I'd have to go the third root, so that's an exponent of 1/3. Here I'd have to take it to the third power and then move it to the denominator, so it's negative 3. Here I have to do the third root of 27 to get 3, so that's an exponent of 1/3, but I moved it to the denominator, meaning it needs to be negative. So now let me expand. We have a log base 2 of 5. Also have a log base 2 of x. That one has an exponent of 3, so that becomes a coefficient. Since it was in the denominator, it's going to be a minus. So that's expanded. Number 23, I'm going to have a log base 5 of 2. A log base 5 of a, move its exponent in front of its coefficient. I also have a log base 5 of b. Its square root becomes an exponent of 1/2, move that out front. Nothing's in the denominator, they're all multiplied, so I can add the logs together. So that's expanded. Now condense. Log base 3, this x is going to be squared. The y is going to be the third power. Since they were added, neither of them go to the denominator, so that's condensed. This one, they're all log base 7, so my answer is going to be a log base 7. You see there's negative, so there will be a fraction. N is going to go in the numerator. 3, this 2 becomes an exponent of the 3, so 3 squared, which is 9, is going to go to the denominator. And then m to the 4th, that becomes an exponent. It's positive, so it stays in the numerator, so m to the 4th. So log base 7 of n, m to the 4th over 9. Here I can exponentiate with a 4, so 4 to the log base 4 cancels, so giving me 4x minus 20. 4 to the 5th power is what I'm left with on the other side, which is 1024. So add 20, 1044, and then we get to divide by 4, giving me 261. Plug it in, it's going to be positive, so we should be good to go. X1, logs cancel with it when I exponentiate to a 9, so the 3x squared is equal to 2x plus 1. I'm going to bring everything to one side. I'm going to try and factor this, hope it factors. 3x and x. I have a negative 3x plus x is negative 2x. Okay, that looks good. So then set each factor equal to 0. Here I'd have to subtract 1, then divide by 3, so I get negative 1/3. This one I'd get a positive 1. Plug them in, negative 2/3 plus 1 is still positive. Negative 1/3 squared here is going to be positive times 3 is positive. Looks like everything, both of them should work. Here I'm going to exponentiate. So x minus 3, it's an inequality, is less than 10 to the second, which is 100. Giving me x is less than 103. I did know, domain-wise, that x minus 3 had to be greater than 0. So x had to be greater than 3. So not everything less than 103 is greater than 3, so I have to include everything between those for my answer. Okay, number 29, I'm going to exponentiate with a 7. So 8x plus 5 must be greater than 6x minus 18. Subtract my 6x. Subtract my 5. Divide by 2x is greater than negative 23 halves. Let's check domain. 8x plus 5 has to be greater than 0. I'd subtract 5 and divide by 8. So x has to be greater than negative 5/8. Here I'd add 18 divided by 6, so that's 3. X has to be greater than 3. In order to be, you have to be greater than 3 in order for both of those to work. So my domain is that x has to be greater than 3. So this isn't fully contained in my domain. The part of this that's in my domain is when x is greater than 3. So I had to further restrict my answer to fit in my domain. Number 3, I can That's an equal sign there, kind of wrote over it. I can turn my 3 into an exponent, so log base 7 of 4 to the third, which is 64, equals log base 7 of y squared. Exponentiate with 7s, cancels out the logs, so 64 is equal to y squared, square root, so y has to be a positive 8, or y has to be a negative 8, but we know that we can't have take a log of a negative number, so we throw the negative out. Positive 8 is the only one that works. Number 31, I've got to condense. So 3u plus 14 is going to be over 15. Or over 5, rather. Okay, so now I can exponentiate with 9s. So 3u plus 14 over 5 is equal to 2u. You can pretend that's over 1. You could cross multiply if you like. So 5 times 2u is 10u. Equals 1 times 3u plus 14, which is 3u plus 14. Subtract the 3u, so I'm left with 7u equals 14. Divide by 7, I get that u is 2. Check, it's going to work in each of my logs, so it's not extraneous. There we go. All right, last two. We have to just condense these. X plus 3 times x is going to be x squared plus 3x. I can exponentiate with 10s. So x squared plus 3x is going to be equal to 4. Subtract the 4. X plus 4 and x minus 1, leaving us with answers of negative 4, positive 1. Check them, test to see if they work. Look at this log right here. We have just a log of x. I can't plug a negative in there. I can't take log of a negative, so I get to throw that one out. So plug 1 in, log base 10 of 1, that's fine. Over here it's fine also. Last problem, we've got to condense those first two logs together. So distribute or FOIL that, n times n is n squared. I'll have a 4n and then a negative 3, and that's going to combine together to make a positive 1n. Then negative 3 times 4 is negative 12. Now I can exponentiate. So n squared plus n minus 12 is equal to, over here I have 8 to the first power, which is 8. Subtract 8, so it's set equal to 0. Factor n plus 5 and n minus 4. So n equals negative 5 and n equals positive 4. Let's test those. If I plug in negative 5, I get a negative log, so I get to throw that out. If I plug in 4, both of them are going to work slow. There's our sole answer.